Okay, so these are the solutions to assignment number 2. So question 1, it says an action figures often come in different sizes. There's the 1/6 model, 1/12 model, and 1/16. So when they say a 1/6 model, if you have a figure, I don't know, maybe it's like Iron Man or Hulk or whatever it is. Here's my person. If you have a 1/6 model, it's literally 1/6 the size. So if I were to divide this guy up into 6 pieces, 1, 2, like so, a 1/6 scale model of that figure would be that big. A 1/12 model would be half that size, and a 1/16 would be even smaller. Okay, so here's the question. This is what are the dimensions of the 1/6 and 1/16 model? And we are given the 1/12 dimensions to be approximately 30 centimeters tall, 30 cm tall. But then we have also like the width and the depth. So I mean, like the width of it is 10 centimeters and the depth of the model is about 4 centimeters. And just making some approximations right there for this question. So for question A, what are the dimensions of 1/6 and the 1/16 models? So first we need to find the K factor. So if you look at question A right here, so we say, okay, our K factor is the scale model divided by the original. So we want to know how big the 1/6 is. So I'm going to put 1/6 up top. This is the size of the thing we're trying to find, and we know the 1/12 one. So if I take my calculator and go 1/6 and divide that by 1/12, we get a scale factor of 2. Hopefully we can also do that calculation without a calculator, because we know that a 1/6 model is literally double a 1/12 model. So if our scale factor is 2 for the 1/6 model, it's right there, 1/6 model, and basically means we can double all those dimensions. So if the original was 30 by 10 by 4, if I double that, we get a 60 cm by a 20 cm by an 8 cm figure. So that is the dimensions of the 1/6 figure. If I want to do the other one, we say, okay, now we're trying to find the 1/16. So I'm going to repeat this calculation, but instead of 1/6, we have 1/16 on top. And we're going to divide that by 1/12. In your calculator, you might need to put brackets around the bottom one for it to divide properly. So I'm going to go 1/16, 1 divided by 16. I'm going to go divide by brackets 1 over 12. And we get 0.75. So 0.75. So 1/16 is smaller than 1/12. So we're going to just multiply each of those numbers, 30, 10, and 4. We're going to multiply it by 0.75. So we get 22.5 centimeters tall by 7.5 centimeters by 3 centimeters. So that is the dimension of our other model. Now there's 2 ways to do part B. It says what are the approximate volumes of each model. So if I actually calculate the volume of the 1/12, so I'm going to do those substitute 1/12. So this is the volume of the 1/12 model. And so all I'm going to do is we're just going to assume it's like a box. The box figure. Yes, in real life, we know these figures are more complex. The head is about a sphere, the torso is like a cylinder. Who knows? We're just going to approximate as a box. I'm going to go 30 cm by 10 cm multiplied by 4 cm. And we get a value of, so we get 30 multiplied by 10 times 4. We get 1,200 centimeters cubed. So how to visualize that, if you take your ruler and just measure a centimeter. So if you have your ruler and say, okay, that's about 1 centimeter. And you make that into a square now. So 1 centimeter by 1 centimeter. If you make it into a cube, 1 centimeter by 1 centimeter by 1 centimeter. To fit, you can take 1,200 of these small 1 centimeter cube blocks. 1,200 of those blocks will fit within this one action figure. That's how we kind of conceptually understand volume. So now our next one we can, for V 1/6, just do the same thing. We're going to multiply 60 by 20 times 8. So 60 times 20 times 8. And we get 9,600 centimeters cubed. And for our 1/16 model, we're going to go 22.5 times 7.5 times 3. So there's actually another way that we can solve for volume. And we have to understand how k squared, and k cubed works. So when we look at this k value for this first one, k is 2. If I cube that number, you get 2 cubes. That's 2 times 2 times 2. That equals to 8. So what that tells me, if my scale factor is 2, what that means is that my volume will increase by a factor of 8. Because we have to recognize that each dimension is doubled. The height got doubled. The width got doubled. The depth got doubled. All of them got doubled. Height got doubled. The width got doubled. The depth got doubled. So if we multiply each dimension by 2, we get 2 times 2 times 2 is 8. So what we can see actually, if we compare this 9600 with this 1200, right? 9600 divided by that 1200. Guess what equals to 9600 divided by 1200? It equals 8. So instead of having to recalculate, all we have to do is say, okay, take your 1200. You just take that 1200. Say, okay, my scale factor is 2. So I'm just going to multiply by that k cubed, which is 8. We would get 9600 centimeters cubed. For my other one, so instead of having to recalculate, what I can say is I can take my 1200 centimeters cubed and say, okay, I'm going to multiply by my k factor. And because we're talking about volume, I'm going to cube it. And I say, okay, 1200 multiplied by 0.75 to the power of 3, and we get 506.25 centimeters cubed, which is identical to what we found just by multiplying length times width times height. This is a very important concept because not everything is easy to calculate like a rectangular box. Sometimes you get much more complex shapes. So instead of having to do a complex mathematical procedure to determine the volume of each individual shape, if you know one, you know all the others for as long as they're the same overall shape, just scaled up or down.